So today I'm going to be going over functions in compiler construction. So I'm just going to be talking about top-level function declarations. So our program has all of our top-level functions and then our main body. And then every function has a name, a parameter. I'm just using one parameter in this presentation, and then a body. And then we also need to extend our expression syntax tree as we call to our function with one argument. It's a very simple program that basically multiplies our parameter by two. So it doubles our input, and we should result in 14. And this is a workflow basically of allocating and deallocating our stack frame, which I'll go into now. So in our very start of our program, where we right here, this is where our instruction pointer points to, we push our base pointer onto the stack. So what does push really do? Push essentially just subtracts our stack pointer by one slot and then moves our base pointer to wherever our memory location of our stack pointer is. Then we move our old base pointer to wherever our stack pointer currently is. So now what's on our stack is actually the old base pointer that we once had. Now we subtract our stack pointer by one slot. So why one specifically? Well, it depends on how many local variables we're actually dealing with, and in this case I'm counting 7 as a local variable, so it'll allocate that. Now we move 7 encoded, which is 14, since we pad a 0 on the right as we did in previous PAs for integers. We move that into racks, and we put that in our local memory stack frame. So in our local memory that we just allocated, that's where it goes. In relation to the base pointer, it's one slot above the base pointer. So then we put, now we're going to prepare for actually calling. So to actually call, we need to push all of our parameters onto our stack before we actually allocate our sub stack frame for our new function, for the function we're calling to. So the way I'm pushing it is through RCX. So I'm going to put 7 on RCX and then push 7 basically on the stack. And now this is our parameter that we actually using for our function. So now let's call our function. So what does that calling actually do? Calling pushes our instruction pointer to the stack, and the instruction pointer is where we currently are, so right here, where we're calling function. And then let's jump to our function label. So now we're actually changing our instruction pointer, and our instruction pointer will be right here. So let's push our base pointer. Now we're going to actually allocate our new stack frame for our func, just like we did in main. So now we're pushing our base pointer and then moving our current base pointer to where our stack pointer is. So now what's on the stack, now what we just pushed, is actually the caller's base pointer. It's actually main's base pointer. So once we ever go back and deallocate, we know where to actually change our base pointer to, back to the original caller's base pointer, which is main. Now let's subtract our stack pointer by 2 because we're dealing with 2 local variables, c and x. And then now let's move 4 onto racks, which is really just 2 encoded. So now let's just put everything that we need onto our local stack frame. But interestingly, we need to retrieve our argument, our actual parameter, which is 7, which is x. So everything is in relation to the base pointer usually. So our local stack frame, if we're ever retrieving a local variable from a stack frame, we decrement our base pointer to retrieve that. But in relation to our base pointer, our parameters are going to be right below our stack frame, so right here. So we need to retrieve that, which is going to be adding our base pointer. So we're going to be adding our base pointer by 2 slots, by 16 bytes, because we pushed right before our stack frame. So now we move that into our local stack frame, and then now, as you know from previous PAs, how to multiply, we're going to be multiplying them, and we result in 28, which is 14 encoded, and on our racks, which is good because that's the correct answer. So now let's deallocate our stack frame for func. So to do that, we're going to move our RSP back down to our base pointer. So now we've deallocated our stack, and let's pop our base pointer. So what does pop really do? Pop basically whatever's in our wherever our stack pointer is pointing to, it puts that in our base pointer. So our base pointer is now pointing to where our old base pointer is, wherever caller's base pointer is, which is main's base pointer. And then let's add our stack pointer by 8. Now let's pop our instruction pointer. So whenever we do return in assembly, basically it pops our instruction pointer. So our instruction pointer is now pointing to call wherever we called from, so right here, because that's what we saved in our stack. And then now let's increments our stack pointer. So now we also increment our stack pointer again one more time. Why do we do that? Well, because we need to deallocate the parameters that we pushed before we called our function frame. Now we're done with the main also. We're done with our, it was just one line. So now let's move our stack pointer and deallocate our main frame 2, which is the same as we did before, where we pop base pointer and return to. So where are we actually returning to? So our instruction pointer returns to the invoker of main. And here's the snack program, here's some general assembly and stuff to think about. The slides will be in the description. And here's some actual code. So when we compile our function definition, we have the same kind of entry and the same kind of exit, and then you just compile the body. But our entry, if you remember that we subtracted our stack pointer by a certain amount, that amount is really the depth of the local variables that we're going to be using, basically the maximum space of our local stack frame. So the way to retrieve that is we need to pre-calculate it, which is through this function. What about call? So when we call, we need to make sure we push our parameters before we call, then we deallocate. Once we're done and we've returned, we deallocate those parameters that we pushed. But if we have multiple arguments, you need to make sure that you compile E1, E2, E3, but then you need to push in the backwards order. Push E3, then E2, then E1, and make sure you add RSP by however many variables that however many arguments that there were. Thank you.